In this video, I will review the defect sampling case and look at a few techniques we can use in JMP. This file has recursive sampling every 15 minutes of one unit and then counting the number of defects of that unit. Sampling is done for 10 days and we have 32 samples per day, a total of 320 samples. First, we'll look at splitting and stacking columns. These are the techniques we can use to look at data in different ways. Go to Tables menu and Split. We can split a column by the values of another column. We are going to split the column of defects by the value of the column of day, so that we can have 10 columns, one for each day, and then list the defects of samples for that day. Defects goes to split column and day split by. We can split defects by day. Remaining columns can keep them all or drop all. We will keep the third column sample and OK. This is a new data table. Opens values of days for each row. Now go to column header, so that one here we can see it lists all those defects for day 1, then for day 2, 3, 4, and so on. And these are the sampling times, the first column. Later we will see for a control chart, we have to put all those samples in one column. So we have to learn how to put back different columns into one. We start from the current file, go back to Tables menu, and stack. We can stack different columns. So these 10 columns, we will send them to stack columns. What happens here is stacking all those values in data grid into one column and then making another column with the column headers. So each one of those observations will be marked in the same row with the column header. And those two columns are called data and label. So the data will be our defects and label the date. If you click OK, you have the initial file, sample, day, and defects. The only difference of this file with the original file is that the day goes through sequence of 1 through 10 and repeats the cycle. We can sort and have the same file. We don't need to really to do this, but if you're going to do that, you can go to Tables, Sort, sort based on day. Can make it from smallest to largest or largest to smallest. And the only difference with the first file is that 10 goes after 1. That's the way the system sorts numbers. You can do another sort by changing the value ordering of day. If you click on the column header, right click under column properties, value ordering. You can see the value ordering here. So 10 should be at the bottom of the list. So select 10 and move down. Apply and OK. Now if we sort this file one more time based on day. Sort under tables by day from smallest to largest. This is exactly like the original file. Now we start investigating the data. Distribution of defects. You can see that the maximum observation of one day is 18, the minimum is 1, median is 11, and the mean of observation 10.3. At this point, we start sampling in different quantities. 1 sample per day or more. Now we have 32 samples per day. We want to show that if we take more samples, then there's more chance to detect shift in outcome. So we start with just 1 sample per day. Since we're going to work with the average of the number of defects per day, we need to start looking at tabulation of the data. Best way to summarize our observations. Tabulation tool on the menu creates a summary table. Here we have a drop zone for rows and drop zone for columns. So any of those variables would drop into rows. We need to drop another variable into columns, and then resulting cells summarizing based on a selected statistics the results for one level of one of these 2 variables. One of the 2 variables must be categorical. Our plan is to drop day into rows zone and defects into columns, so that we can have the summary of defects per day. So we drop day into rows, we have these 1 to 10, and then defects on the top right cell. The default statistics is sum. We need to work with the mean, so we drag mean right over this box and release it. That's the mean of each day. We can add any other statistic to this table. If I drag n, which is the count, on this mean for a statistics cell, I don't drop it in the middle, just on the side, either side, right or left. On the left, if I release it, it will also give me the count of those observations per day. If you're going to have 1 sample per day at 9:30, we can filter the data. So this will be the base, and adding the filter. Add sample to the filter. Let's say local data filter. Right click on 9:30. I do have just 1 selection per day at 9:30. And the mean, which is in fact the same observation because we have just 1 observation. To look at the distribution and plot of this number, we can save the results as a table. So go under Tabulate and Make into Data Table. I will save this table as Table A because this is the results of sampling scheme A. So File, Save as Table A. I can look at the distribution of the mean of observations. 11.2. Even save this as a script. Under the top drop down, script, save script to data table. I will keep this and then compare the results with other sampling schemes. We have 5 different sampling schemes. This is the first one, just 1 observation, and the last one will be all observations. Close this table for now and go for 2 samples per day. Sampling scheme B, 9:30 and 2:30 in the afternoon, 14:30. So if I hold Control key and click on 14:30, both sampling times are selected. We have 2 samples per day and then the average of the observations. Repeat the process, save or make into data table. Save this table as B. And look at the distribution of mean. I will save this distribution as a script. And save the table. Sampling scheme C starts at 8:30 and will sample every hour. So I will hold Control key and select on local data filter 8:30, 9:30 and continue every hour. Total of 8 observations per day. Make it into a data table. Look at the distribution of the means and save this script. And save the table as C. Sampling scheme D is starting 8:30 and sampling every 30 minutes. So I will hold Control key and select at every 30 minutes. Will be a total of 16 observations per day. Make into data table and do the distribution of the mean. Save it to compare with the other distributions later. And save the table as D. Well, the last scheme includes all observations. So I clear the filter. I have 32 observations and look at the means. Make into data distribution. And save the distribution as a script. This is table E. In order to visually compare all those distributions, we have to put those histograms in the same scale. So I will start from sampling scheme A. This is table A. Run this script to open distribution. If you right-click anywhere on histogram, go to size scale from the pop-up menu and go to x-axis. You will see the minimum and maximum of the axis is 3.10 to 20.80. We can make it 3 to 20 and do this for all these graphs. This is for sampling scheme A. For B, we do the distribution run. Right click, go to scale, x-axis, same thing, 3 to 20. Same for C. D and E. Now we can observe, as we add to the number of samples observed per day, we can see the distribution, clearly compare the histograms and the range. We can look at the range 6 to 17 and how dispersed the results are. One observation. Go to B, 2 observations per day, 6 to 13, 8 observations per day, the range is 8.5 to 12, 16 observations per day, the range is 9.25 through 11.25, and then 32 observations. The range is from 10.15 through 10.875. So what are the standard deviations? The standard deviations shrink as we add to the number of observations. So more observations will have more consistency in the results. If there is any shift in the results, we can detect it better. The standard deviation of 32 samples per day is 0.21, while the standard deviation for 1 sample per day, 3.08. Next step, we will plot all those results on one graph using overlay plot. To create a plot, I will copy paste all those results of means from all tables to one. You can select one of these tables. I'm selecting table A. The mean of defects, I will change the name to A as the sampling scheme. To paste the results from another table, I have to create a column here. Simply double clicking one of those blank columns, it will create a column. From table B, I will select the header of the mean, copy, Ctrl C, and then select this header of the blank column, paste, Ctrl V, and double click, change the name to B so that we know these are samples from sampling scheme B. Do the same for the other 3 tables. When you put all results into one table, you can create an overlay plot in 2 different ways. Either Graph Builder and adding all these 5 columns all into Y area and day into X, and creating a line graph or smooth it. We can see that E sampling scheme has the smoothest line among all, and A has more variation comparing to all other curves. You can see as we add to the number of samples, the variations will shrink. This is one way. The other way is to stack all these 5 columns into one. Table and stack. Stacking A, B, C, D, and E into one column. The data will be mean defect and the label is scheme. If you click OK, you will have the file and then create the graph. Mean defect into Y and day into X. We can create a line graph, which is putting all those schemes together. Then separate them by scheme. If you drag and drop a scheme into overlay, it will separate based on the label of a scheme. We can see the same graph. The most consistent scheme is E, and then we can see day 1 through 9 there's not much variation, but then there's a shift through day 10. You can clearly see that. And these lines also reflect those ranges we observed in distributions. The smallest range belongs to E, and you can observe the ranges here as well if you add a local data filter and add scheme to the filter by selecting any of those schemes, you can see the curve covers the entire area of the graph. And look at the left side axis, you will see it's from 5 to 17.5. B, C, D, and E. Can clearly see the shift from day 9 to 10, and look at the scale comparing to the first one. It's from 10.1 to 10.9. So the larger the number of observations or the samples per day, the more consistent results we have, and we can detect the shifts if they exist. I will continue this discussion in the next video for control charts.